How many minimum coplanar vectors of different magnitude are required to get a zero resultant? So just remember this thing, if we are having a single force or a vector, then resultant cannot be equal to 0. But if you are considering that there is another vector of same magnitude in the opposite direction, then the value of resultant will be equal to 0. So if they are asking what is the minimum number of force required or minimum number of vectors required to get a resultant as 0, then the answer is nothing but 2 if both are having same magnitude and opposite direction. Now, how many, in question they are asking how many minimum coplanar vectors of different magnitude. So in the question it is given that different magnitude, so not same magnitude. If it was same magnitude, then 2 will be the answer. Now if the magnitudes are not same, then the minimum number of vectors required becomes equal to nothing but 3. So they are, and one more thing is they are on the same plane. So 1, 2 and 3. So while adding these 3, we'll get the resultant is equal to, we may get the resultant is equal to 0. If we are adding 2 and 3 and the resultant of 2 and 3 is same as like 1 but in the opposite direction, then the resultant becomes equal to 0. So remember that minimum number of force required is 2 if they are having same magnitude. If they are not having same magnitude, then minimum number of force required is 3. Then the forces should be coplanar. Now in some question they'll ask if how many forces are required for getting resultant as 0 if forces are non-coplanar. If forces are non-coplanar, then we'll get, then we required 4 forces, means the addition of first 2 forces, if it is equal and opposite to that addition of other 2 forces, then the resultant becomes equal to 0. So actually that is in non-coplanar, means not on the same surface. So it should not, we cannot actually represent it on a surface something like this, but remember that we required minimum 4 forces in that condition.